All right, Norton just reared its ugly head. Um, it stopped me from using my webcam. Yeah, that program keeps updating. Windows keeps updating. Foxfire keeps updating. It's getting very hard to do anything on my computer because everybody wants to make money. Everybody wants to sell you something. Google, when you search Google, they're supposedly going to show commercials now. Okay, that's the latest I heard today. But I wanted to show you the second board. Here's the second board here. Okay, now this one had the RF preamp, toroid coils into a mixer, an NE602. Out of that, it goes right to another mixer. Now, to go from the output of one mixer to the other input of the other mixer, you use a 0.03 microfarad capacitor to 0.05 microfarad. It's not real touchy. Now, to add another, this has a crystal, and this uses the variable oscillator that's over here. Now, in order to feed that in, you feed it in through on pin 6 of the NE602. It's a 47 picofarad cap. There are other ways that they show. They show you using a resistor and a larger capacitor on pin 6, but what that does is it could mess up your oscillator, and it was messing my oscillator up. So I went looking, and I found that someone else used a 47 picofarad on pin 6. Okay, now on the output of the second mixer, you're going to need a little transistor to bring the signal up before you go in your 455 IFs. Now it's a regular 455 IF, 455 crystal, and another 455 IF to a detector diode. I used a 1957 detector diode just for the fun of it. Works. It really needs to be put in a metal box with some basically shielding, okay, because it's doing some wacky weird things as you move the wires around. But the whole project that you're looking at was to do dual conversion. So in other words, CHU Canada comes in here at 3.33 megahertz. You have a fixed oscillator of 6 megahertz into the mixer, and it comes out at 2.67 megahertz. And then this oscillator is running over here. It's running at 3.125 megahertz. It's been pre-scaled to read 3.33 megahertz. And out of this chip comes 455 IF. CHU comes down to 455, goes out, gets detected. Okay, it's a lot to understand, but in other words, this circuit converts the 3.33 megahertz CHU Canada 2 times. Okay, that's dual conversion. That's what I wanted to do. Now, you also need another circuit board with a 455 oscillator for your BFO so you can get sideband. Didn't do that. This whole project was to build a dual conversion receiver from scratch and use modern parts, and I did, except for the 455 IFs. You could argue that's old school, but in other words, an NE602, it's a quite old chip, but it's the standard. And what I discovered was the tricks would be it does the NE602 does have a 18 dB gain on the input. That's why you see a lot of people driving the NE602 with a coil, tuned coil from the antenna right into it, and that amplifies and mixes it with the oscillator, and out comes a signal that's really not that strong. So if you're going to another mixer, it'll work, but then that output needs to be brought up a little bit with a transistor. And you may even want to put the transistor between the two mixers. But you also need some AGC in there, okay, where you decide to put your AGC. Because as the signal's drift in and out on short wave, you might hear your circuit overload because it really needs an automatic gain control circuitry in there. This is straight through. You know, was it manual? It'd be manual volume control, MVC. That's what this circuit is. And I just wanted to understand how you shift the frequency and then what goes with that. Now, I told you, if you're working with the 80 meter band, the Collins uses a 5.7 megahertz crystal. I used the 6 because that's what I had. And you want to keep the oscillator in the mixer of your first converter within 2 megahertz of the incoming signal. And what that does is the output of that first mixer is within a smaller range, so your next oscillator can track that. Okay, so you can go up in frequency, but if, say, you want to get 7 megacycle, you would switch in a 9 megahertz crystal. Don't force that 9 megahertz crystal to try to do 80 meters. Use the 9 megahertz to do 40 meters. Okay, there are tricks. There are tricks to these circuits, and I know only a few of you people out there are going to attempt to build something like this, and I couldn't find anything dual conversion. Everybody copies basically this circuit here. They build a direct conversion, and what happens is you know your input frequency is very close, within a few thousand cycles of your mixer. So in other words, CHU Canada would come in here at 3.33, and then you would use an oscillator that's very close to it within 1,000 cycles. And CHU Canada, you can understand what the guy's saying, but it's very like regenerative. Now, if it's a sideband signal, it sounds absolutely clear. Okay, so that's why for direct conversion they use the NE602. Very simple circuit. It works very well. It's great for QRP. Yeah, QRP rigs. I hate when they use these. I think they're acronyms when you use 3 letters. Well, anyway, yeah, okay. You direct conversion stuff, you can use NE602. But on my mind, I'm saying, well, can I use an NE602 to do 2 different mixers? Then I wanted to understand why there's several crystals in the Collins R388. Okay, I want to understand that circuit. So what they do is they come into a network, a coil network at the frequency range, say 80 meters. They amplify it a little bit. They send it over to a mixer. And then the mixer down converts the band, the 80 meters, they down convert it in frequency. And then they go over to this big honking ferrite knob, ferrite plunger oscillator. And you're looking at that going, well, how do they change the frequency range for the higher frequencies? Well, they keep down converting the frequencies to that range of that oscillator, and that's the trick. Okay, once you understand that, okay, and you don't put a 10 megahertz crystal in there and then down convert it, you get a sloppy mess, okay, and you lose a lot of gain. The NE602 really doesn't give you a lot of range if you down convert too much, okay. You'll get a signal, but it'll be very weak. But I just wanted to show you, this is the length I go to just for something I thought of. Like, well, how would you do that? Well, let me see how they did do that. Why are they doing it that way? So as I get all those different questions in my head, I basically start building stuff. And I'm like, why did they do it that way? And then I can't come up with a better way. Or I do think I come up with a better way, and then I try it, and it's not worked as good. As I said, you know what? Go do what they did first, then come back and figure out why. And that's what you do. I do experiments, and I don't work all day on this anymore. I've been taking a lot of long walks. I try to do yard sales, but it just seems to be raining every Saturday. But in other words, as I'm walking, I think about the circuit. What test do I want to do tonight? That's another thing. 80 meters really doesn't work that well until after the sun goes down. Well, the sun goes down 8:30 at night, 8:30, 9 o'clock at night. can't even get CHU Canada during the day, during the summer here, okay? So in other words, in order I have to wait, oh, and then I have to shut my computer off. Other things have to be off in order for 80 meters to work really well. And so just before bedtime, I have all these different little tests I want to do real quick. I set up during the day. I wire the circuit up sometimes during the day. Get it ready, send some signals through it. And then at bedtime, I do my checks and see how it worked out. And I realized after you go through 2 mixers, you're going to need a transistor in there. It's like an NPN small signal. It might be a 2N 3904 or 3907, whatever it is. It's down in there. I edited it in there so I had enough oomph to go through that 2 IF cans and a crystal filter, because they're called passive components. In other words, when you put a signal through a passive component, it comes out the other end less. And if you have 3 of them, you got even less signal coming out. So you want to boost it up before it goes through the 3 passives. And I have all this stuff in my head. I spent many years working on this stuff. And lately I just find myself fighting with Windows, and Norton wants to sell me LifeLock. And, you know, it's become harder and harder and harder to deal with that computer. And then the program, the video editor program, I'll put my video in it and it compresses it. And then I'll walk away and come back. It just went to Never Never Land. I have to do it over again. Yeah, I'm fighting everything lately. Everything's becoming a task, and you probably know in your life things are not getting any easier. And this is really hard technical stuff. I'm 71. I realize my memory's not as good as it was. It's still good, but you know, and I'm walking along and I'm like, well, let me try this tonight. Well, how come they did it this way? And you can't find any of this information, okay? You can really dig, and you'll notice a guy that's got a pretty good book out. He sort of starts mentioning certain things, but he doesn't go any further. And I'm hoping, you know, like I said, get the NE602s. You know, you can go from one into another. You have your 2 different oscillators. One's fixed. Look at the first thing you want to do is look at the Collins R388. Middle of the page to the right, you'll see the crystal oscillator, and that down converts the band you're on. And then look at that freaking big ferrite, what would we call it? It's a big cylinder, and it's cool. I repaired a few of those radios, and like, why did they do that? Well, at that time, that's the only way they could do it. Now, you could take a one of them digital synthesizer RF generators and use it for this guy. But what I did was I used a regular digital readout from eBay with my own oscillator, my own Franklin oscillator, and it produces less hash. Okay, anytime there's a microprocessor, you're going to get extra hash. Even this eBay digital display, it produces hash, and you don't want that on shortwave. But if you shield things, you can tolerate it. And everything in electronics is a compromise. What are you trying to accomplish? Well, you do this, do that, but then this, then that, and that will screw you. And then you try to work around things, and you know, and then you go look at that Collins radio done in tubes, probably better than any circuit you could probably make. Okay, and the readout, there's a big block of wood that rotates, and that is very accurate. The readout, only part of the band is on that big piece of wood. So I won't say you can get it within a hertz, but yeah, you can get it within a hertz. And but the radio is big, it's heavy, and really there's really nothing on 80 meters at night except CHU Canada. You got your AM hams, you got your sideband guys, and code guys, and code's getting less and less and less. And sometimes they have a contest, and then it'll be really active. The weather conditions will be good. But, you know, it's the band I listen to just before I go to bed. I'll flip it on. And if the hams are talking about anything but politics, I'll leave it on. I'm an independent voter. I don't want to hear about Biden or Trump. I'm worn out. I'm absolutely worn out at 71. I think that's it. All right, that's it.